Space, the final frontier. The words of Gene Roddenberry resonate with many people, especially those who wish to make his works of fiction a reality. Scientists and astronomers strive to further man's reach in the universe, but also his grasp and his understanding of the universe, our galaxy, and our solar system. By learning more about our neighbors in the solar system, we can learn more about our home here on planet Earth. Tonight, I'd like to inform you about the New Horizons mission, some components of the spacecraft, and what its journey will tell us about its destination, Pluto and the Kuiper Belt. The New Horizons mission is part of a larger New Frontiers mission, which was implemented in 2003. New Frontiers is, as NASA states, a strategy to explore the solar system with frequent, medium-class spacecraft missions that conduct high-quality, focused scientific investigations designed to enhance our understanding of the solar system. The New Horizons mission is the first of a potential 10, which will send spacecraft to Venus, Jupiter and one of its moons, Saturn, again to our own moon, as well as the surface of a comet, much like the European Space Agency's Rosetta missions. Specifically, New Horizons mission is to map and characterize the surface of Pluto and Charon, search for and characterize the atmosphere of Pluto and its escape rate, record surface temperatures of Pluto and Charon, search for additional satellites or moons, and continue on to study KBOs, or Kuiper Belt objects. New Horizons was launched on January 19, 2006 from Cape Canaveral, Florida. What's unique about New Horizons is it was launched at a speed of 36,373 miles per hour, making it the fastest spacecraft ever to leave Earth's orbit. Its flight path took it past Jupiter, where it gained an extra speed boost, and it also had the opportunity to practice some maneuvering and take some great shots. Right now, New Horizons is 34.09 astronomical units from the Sun. 1 astronomical unit is the average distance between the Earth and the Sun, which is about 93 million miles. So this means that New Horizons is currently about 3.17 billion miles from the Sun, and it's traveling at 14.45 kilometers per second. By comparison, if you were to stand on the goal line of a football field and fire a gun towards the opposite end, at its current velocity, New Horizons would reach the other goal line by the time your bullet traveled 10 yards. The probe itself is quite a piece of technology. It's about the size of a grand piano and weighed about 1,054 pounds when it was launched. It's covered in insulation like a thermos with an aluminum frame. It's a triangular shape, much like a piano, with a large 83-inch radar dish on one side and an RTG sticking out of one corner. The RTG is an integral part of New Horizons because it will supply all the power and the heat for the entire length of the mission. The RTG is a radioisotope thermoelectric generator. It uses radioactive fuel, in this case plutonium dioxide, relying on the heat given off by the fuel's radioactive half-life and turning the heat into electricity, which it uses to power all operations. When launched, the RTG was recorded at 425 degrees Fahrenheit. When you convert this to electricity, it supplies 245 watts of power, which will eventually diminish over time. But all the devices on the probe only require between 2 and 10 watts of power, which is about as much as a nightlight, and they're never operating at the same time. The RTG is insulated from the observation equipment as to not interfere with the recording and observations, but also because the observation equipment works better when it's colder. But the RTG does warm the body of the capsule and keeps the probe and all of its processors at about 50 to 85 degrees Fahrenheit, even in the depths of space. New Horizons doesn't have a propulsion system because it doesn't need one. It was launched at such a high speed, it doesn't require anything, and it also received about a boost of about 4 kilometers per second when it passed Jupiter. The probe does, however, rely on small thrusters. It has 16, it has 4 thrusters that are used for course corrections, 12 smaller ones are used for aiming and for spin control. These thrusters use hydrazine as propellant, which is held in a titanium fuel tank. It contained 170 pounds when it was launched, and it contains about 30 to 40 pounds right now. It's important to note that New Horizons will only use about 8 thrusters. Unless they are damaged or they fail, it has 8 backup thrusters. And many of its systems, including its processors and memory, are redundant. New Horizons has several instruments to record all kind of data along its journey, and they all have pretty cool names. Rex, Lori, Swap, Alice and Ralph, Pepsi, and the SDC, or the Student Dust Collector. Alice and Ralph are imagers, they're spectrometers, and they're a type of camera. Alice provides ultraviolet imaging, while Ralph captures visual and infrared spectrum compositions. Rex is a radioscience experiment. It's a passive radiometer that measures atmospheric composition and temperature. Lori is a long-range reconnaissance imager, another camera that takes really high-def pictures. SWAP is a solar wind around Pluto. That's what it stands for. And that's to measure plasma, and it's a spectrometer, and it's used to capture composition as well as the escape rate of the atmosphere of Pluto. The Student Dust Collector is managed by students, and it was built by students at the University of Colorado in Boulder. And it's going to measure the composition of space dust that the probe comes in contact when it's on its journey. The navigation system relies on a complex star map consisting of 300 stars. It takes a wide-angle picture 10 times every second and uses it to orient itself. It also has a sun sensor and onboard gyros for inertia measurement. It relies on 3 antennas to communicate with Earth, and they're all stacked one on top of the other, a low, medium, and high gain. New Horizons has to point towards the Earth in order to communicate because we're so far away, 3 billion miles. At its current position, it takes a long time to talk to New Horizons. Sending radio signals which travel at the speed of light. It takes almost 10 hours round trip. New Horizons can only send information at about 1,000 bits per second, which is important. This means that all the data that New Horizons has collected in its flyby of Pluto will take 16 months to send back to Earth. So we will be receiving much more information all of next year about events that happened this last July. New Horizons started its journey in January of 2006, and it's been traveling the entire time. When New Horizons was launched, we still had 9 planets in our solar system. Since then, Pluto has been reclassified as a dwarf planet. It was declassified as a planet in August of 2006 because it did not meet new criteria for being a planet. To be classified as a planet, an object must orbit the sun, be massive enough to be rounded by its own gravity, and it must clear the neighborhood of its orbit, meaning in its own orbit, a planet has to be the big kid on the block, and Pluto isn't big enough. Pluto was discovered by Clyde Tombaugh in 1930. In his honor, 1 ounce of his ashes are on board New Horizons. Pluto is small. It's about 2/3 the diameter of our moon, at about 1,400 miles across. You would weigh 1/15 of what you weigh here on Pluto, but you wouldn't want to go there because its surface is almost 400 degrees below zero. A day on Pluto lasts about 6.4 Earth days, and a year on Pluto is 248 Earth years. The last time Pluto was where it is now was 1768, before the United States was a country. Pluto's orbit around the sun is very long, but also very unique because it is very eccentric and elliptical, meaning it doesn't travel around the sun in a circle with the sun in the center. It's so eccentric that for 20 years it is actually closer to the sun than Neptune. While most planets spin on the same axis as their orbit, Pluto spins perpendicularly, meaning it spins on its side while orbiting, and Charon follows around its equator. Charon and Pluto's relationship is also unique in that they are in a spin-lock phase. This means that Charon orbits Pluto at the same rate that Pluto spins. One side of Pluto has never seen Charon, and one side of Charon has never seen Pluto. Charon was discovered in 1978, but until the New Horizons mission was only seen as a bulge. Charon is actually just over half the size of Pluto, and because of this, Charon's gravity causes Pluto to essentially orbit itself. Pluto has 4 other satellites, or moons: Nix, Hydra, Kerberos, and REO Speedwagon. That's actually Styx. While Nix and Hydra were discovered in 2005, it was the New Horizons probe that discovered Kerberos and Styx. New Horizons was named after Nyx and Hydra, NH. Soon, we hope to be receiving more and more data back from New Horizons, and what it will tell us about Pluto and the Kuiper Belt will tell us more about our own planet. As Pluto and Earth are the same age, we will learn a lot about how worlds develop and how the universe, and specifically our solar system, can shape them. I hope you find this information interesting, as it will tell us more about where we live, because we don't just live on planet Earth. This is our solar system, this is our galaxy, and our home. New Horizons and all the New Frontiers missions will hopefully continue to teach us more about the universe we live in, and someday lead us to boldly go where no man has gone before. Thank you.